Good morning, students. Students, this lesson is of class 9th for the subject of physics, topic critical angle and total internal reflection, which is covered in chapter 4, refraction of light at plane surfaces, and is on page number 92 of your textbook titled Concise Physics by Selena Publications, and is being submitted to you on 17th November 2020. All students may now open page number 92 in front of you. If all students are ready, then let us start with our topic for today, that is transmission of light from a denser medium to a rarer medium at different angles of incidence. Students, kindly see the sequence of medium. The topic is transmission of light from denser medium to a rarer medium at different angles of incidence. I will be drawing 3 different cases having 3 different values of angle of incidence, which will be written as small I. So we will be writing angle of incidence as letter small I as compared to critical angle, which is written as letter I with the subscript of C. Critical angle. So students, 3 different cases having 3 different values of angle of incidence as compared to critical angle. A particular angle for different medium with respect to air. Students, this critical angle, what is this? It is a particular angle for different medium with respect to the surrounding medium as air. And its definition we will be doing in our next topic. So first of all, case 1 is when our angle of incidence is less than critical angle of the medium. Now students, see figure number 1 in front of you. In this figure number 1, we are having 2 different mediums. One is glass and the other is air. As you already know that air is a rarer medium having refractive index as 1, while glass is having more refractive index as compared to that of air. So glass will act as a denser medium, while air will be acting as rarer medium. So students, see here, glass is acting as denser medium because its refractive index is more than that of air. So air is acting as rarer medium. Now here we will be drawing the light of incidence as shown in figure number 1. Light AB is representing incidence ray. So the light is incident from glass to air. This light is coming from point B to the surface A. When the light reaches at point A, there is change in medium from glass to air. So the light has to go in the same direction, but due to the change in medium from denser to rarer, the light will bend away from the normal. So the path of light is changed, and this A to D ray is known as refracted ray. So AD is refracted ray. Now students, when the light is incident at point A, most of the light is refracted, while a very less percentage of the light is reflected also. So BA is our incident ray, while AC is our reflected ray. And here in this case, our angle of incidence was less than critical angle, and this angle made by refracted ray and the normal is known as angle of refraction. And clearly this angle of refraction is greater than angle of incidence, while the angle made between reflected ray and the normal is known as angle of reflection, and according to law of reflection, angle of incidence should be equal to angle of reflection. So in figure number 1, angle of incidence will be equal to angle of reflection. So in diagram number 1, when a ray is incident from denser to rarer medium, then the ray bends away from the normal as it travels from denser to rarer medium. Most of the light is refracted, while a very less percentage of light is reflected back in the same medium. Now, students, let us observe figure number 2. In this case, our angle of incidence is now equal to critical angle of the glass. So when the ray BA is incidence from glass to air, and if angle of incidence is equal to critical angle of the glass, then refracted ray occurs at the boundary or the interface of glass and air surface, such that angle of refraction in this case is 90 degree, because the angle between refracted ray and the normal angle of refracted ray and the normal is 90 degree. So angle of refraction is 90 degree, while part of light is reflected back in the medium, such that angle of incidence and angle of reflection are equal. So students, in case 2, when angle of incidence is equal to critical angle, then angle of refraction is 90 degree and the refracted ray is along glass air interface. Interface means boundary between glass and air. And the refracted ray is very weak. Now, we will come to case number 3. Here, angle of incidence is greater than critical angle of glass. When angle of incidence is greater than critical angle, then there is no refraction. That is, the entire incident ray reflects back in the same medium, that is glass, and no refraction occurs, and this process is known as total internal reflection. Students, pay attention. Since the light has not changed its medium, hence we will be using the term reflection instead of refraction. So here now we will come to our next topic, that is total internal reflection, which is also termed as TIR, capital T, capital I, capital R. So students, when a ray of light traveling in a denser medium is incident at the surface of rarer medium at an angle of incidence greater than the critical angle for the pair of media, the ray is totally reflected back into the denser medium. This phenomena is called total internal reflection. Students, now pause this audio video and write down the two essential conditions for the total internal reflection to occur. After you have written the answer, then you can resume further to check your answer. So students, the two necessary conditions for total internal reflection to occur are, firstly, the light ray must travel from denser to rarer medium. Students, the light, as done in our example, was traveling from glass to air. If light is coming from rarer to denser medium, then TIR will not occur. So the first condition is the light ray must travel from denser to rarer medium. And secondly, the angle of incidence must be greater than the critical angle for the pair of media. Students, note that in the process of TIR, 100% energy or intensity of light is reflected back, while in other devices such as plane mirror, 100% reflection is not possible. Why? Due to refraction and absorption of some part of light. So students, now let us learn about the definition of critical angle. In the definition, pay attention to the sequence of medium written. So students, as we discussed in case 2, if angle of incidence is equal to critical angle, then the refracted ray is making an angle of 90° with the normal. So students, if angle of incidence is equal to critical angle, then angle of refraction is 90°. It should be noted that angle of incidence is made in denser medium, corresponding to which angle of refraction is made in rarer medium. So students, now we can define critical angle as critical angle is the angle of incidence in the denser medium corresponding to which angle of refraction is 90° in the rarer medium. So critical angle is the angle of incidence in the denser medium, corresponding to which the angle of refraction in the rarer medium is 90 degree. Now let us learn the relationship between critical angle and refractive index. Now students, in figure number 2 drawn on page number 2, if we apply Snell's law at point A, then what will happen? Now see point A. In figure number 2, this is our point A. At point A, the refractive index of glass divided by the refractive index of air will be equal to, now students see, in glass, the angle made here at point A is angle of incidence, which is equal to critical angle. So, according to Snell's law, if glass is written in the numerator, then its angle in the medium is written in denominator. Similarly, refractive index in air is written in denominator, and in air we are having an angle of refraction which will be written in numerator. So students, refractive index is inversely proportional to the sine of angle in the medium. So if glass is in numerator, then the angle made in glass will be in denominator. Now angle of refraction is 90 degree, and as we know that sine 90 is equal to 1, while refractive index of air is also equal to 1. Hence, we will find that refractive index of glass is equal to 1 divided by sine of critical angle. And in general, if there are two different mediums, then we can say that refractive index of denser medium is equal to 1 divided by sine of critical angle. So in general, refractive index is equal to 1 upon sine of critical angle. Students, refractive index is inversely proportional to critical angle. That is, more is the value of refractive index, less will be the critical angle. Now students, out of diamond and glass, which medium will have more critical angle and why? Now you may pause the audio or video and write down the answer in your physics notebook and then resume further to check your answer. So students, the answer is, as refractive index of diamond is more, we have studied this earlier, that refractive index of diamond is maximum. That is, the refractive index of diamond is 2.41. Thus, critical angle for diamond is less as compared to glass. Since refractive index of diamond is maximum, thus it will have least value of critical angle. Now students, let us learn about the factors affecting the critical angle. The critical angle for a given pair of media is inversely proportional to refractive index of denser medium, and thus critical angle depends on two more factors. Firstly, color or wavelength of the light. Now students, critical angle is inversely proportional to refractive index, and refractive index is inversely proportional to wavelength. Thus we can say that critical angle is directly proportional to the wavelength of light. So, critical angle is inversely proportional to refractive index, while refractive index is inversely proportional to wavelength. So, we can say that critical angle is inversely proportional to refractive index. Thus, it makes that critical angle is directly proportional to wavelength of the incident light. That is, the critical angle increases with increase in wavelength of light. Now students, temperature of a medium is our second factor on which critical angle depends. Critical angle is directly proportional to temperature of a medium. Thus, critical angle increases with the increase in temperature. Now students, today we studied that critical angle is inversely proportional to refractive index, and earlier in exercise 4a we have studied that refractive index is inversely proportional to temperature. Thus, combining the two results, we can say that critical angle is directly proportional to temperature of the medium. Now students, let us observe total internal reflection in terms of a glass slab. So if you see further, here in this apparatus of a glass D, that is a semicircular glass slab is taken, and we have marked angles from 0 to 90 degree in first and third quadrant. Now students, the critical angle of glass slab varies between 40 degree to 42 degree. And in this experiment, we will be incidenting light from third quadrant. The light will pass from the glass slab and will be seen in first quadrant, that is the refracted ray. Gradually, if we increase angle of incidence from 0 to 10, 10 to 20, 20 to 30, 30 to 40 degree, we will have a ray of light coming on the first quadrant. But as soon as we increase the angle of incidence beyond 40 degree, then the ray of light will be seen through the fourth quadrant, which will be known as total internally reflected ray. Now observe here, if the ray of light is incident from 0 degree, then the ray passes from glass slab to the air, and this is the case of normal incidence. Normal incidence means angle of incidence is 0 degree. Now see here, the light is incident at 0 degree and the light is refracted in the other medium at 0 degree. So this is the case of normal incidence. The light is changing the medium and its speed also changes, but there is no change in the path of light. Now further, we will be increasing the angle of incidence from 0 to 10. Now you can see at this point the angle of incidence is 10 degree, while the light coming out is from first quadrant and its angle is 15 degree approximately. So angle of refraction is greater than angle of incidence. Similarly, if we go beyond 20 degree, see the angle of incidence in this case is 20 degree, while angle of refraction is 30 degree. Now further, moving to angle of incidence 30 degree, your angle of refraction is almost 50 degree. Similarly, now you can see students, a very weak ray is coming on fourth quadrant also. This weak light is reflected light, but its intensity or brightness is very less, since most of the light is coming in first quadrant. That is, most of the light is refracted from glass to air. Now see, slowly, when you are increasing angle of incidence, angle of refraction is also increasing, and now the brightness of reflected ray has increased from our previous observation. Now students, see what happens. As soon as the angle is reaching 40 to 42 degree, the brightness of reflected ray is increasing, while slowly this refracted ray will vanish as soon as it reaches beyond 85 degree. See, now at this place, what can we observe? That as soon as the angle of incidence is 42 degree, angle of refraction is 90 degree, and what happens here? A very weak refraction, which is not even visible to us, occurs. You can see a certain light on the surface. This is the refracted ray, while your reflected ray has brightened now. Now further increase in angle of incidence will increase your total internal reflection. So students, see, now if you increase angle of incidence further, there is no light in the first quadrant. Whole of the light has entered in fourth quadrant, while first quadrant there is no refracted ray. Now since the light is coming back in the same medium, this light is known as reflected light, and since it is internally reflected, this whole process is known as total internal reflection. Whatever is the angle of incidence in this case, the same will be the angle of reflection according to the law of reflection.